Hello everyone. This is our assignment for BMII1112 Introduction to Industrial Engineering, and we are from Group G. This assignment has two parts. The first one is to develop a convincing argument to demonstrate that industrial engineering is a true engineering discipline compared to civil, chemical, electrical, and mechanical engineering. And the second part is to identify and describe case studies that show how industrial engineering principles and methodology can be applied to non-manufacturing systems. These are our group members, which are Manushree, Iru, and me, Hui Ling.
First of all, I would like to give definition for the true engineering discipline to understand the need of the question in assignment. A true engineering discipline is a field that applies scientific knowledges, mathematics, and engineering principles to design or improve systems. So, for example, civil engineers they design bridges and buildings using physics like physics theory and calculation. Similarly, industrial engineers design and improve complex systems like factories or hospital supply chains that dealing with machine, people and material. This shows that industrial engineer fits to the definition of a true engineering field. Next, the first argument that I choose to prove that industrial engineer is true engineering discipline is industrial engineer has a strong scientific and mathematical foundation. So same like other engineering fields, industrial engineer also use similar scientific methods. So one of the example is optimization equation. This the IE engineers use the optimization equation to determine the most efficient production schedule. So it's just like mechanical engineer use equation of motion and civil engineers use structural formula to calculate like beam strength. And another example is linear programming. This is a mathematical form methods, and this one is the real optimization equation used in industries. These prove that industrial engineering relies on mathematics and scientific foundation. The second argument is industrial engineer designs and improve complex engineering systems, i.e. focuses on designing, optimizing and improving complex systems. So, for example, a mechanical engineer may design a single machine, but industrial engineer design the entire production process so that the machine, workers, and material all work together. So, I also provide an example of production line. It shows that industrial engineer have to optimize that how raw materials enter the production line, then how workers able to work with the machines until the product delivery. Industry engineers just want to make the entire system efficient and productively. If got any problems in any part of production line, the engineers should provide a solution. This is why industry engineer is crucial and this proof industry engineer fits to the true engineering discipline. Furthermore, the third and last argument is industrial engineer recognized globally as a core engineering field. Industrial engineering programs are fully accredited by major engineering bodies such as Engineering Accreditation Council in Malaysia, ABET in United States, and other international engineering bodies. Industry engineers are credited for scientific analysis, problem-solving techniques, and engineering design. This includes optimization and operation management and research. Hence, the top universities like Georgia Tech and NUS in Singapore, and also in our country, University Malaya and UTEM place engineering under the Faculty of Engineering. This means these all universities treat industry engineer at the same level as mechanical, electrical, and civil engineering. This global recognition proves that industrial engineering is a major engineering field.
Next, I'll be presenting a case study that demonstrates how industrial engineering principles can greatly improve government operations. In this assignment, our focus will be on the Department of Motor Vehicles, or in Malaysia, Jabatan Pengangkutan Jalan Raya, which is commonly known as the JPJ. It is an organization often criticized for long wait times, inefficiencies, and customer dissatisfaction. This case study will show how industrial engineering can transform such a system into a much more efficient and user-friendly service. So, before the industrial engineering intervention, JPJ was facing multiple issues. Customers often waited anywhere from 1 to 3 hours for basic services. The lobby was overcrowded, paperwork errors were common, and staff were overwhelmed. These problems led to frustration not only for the public but also for the employees. Recognizing the need for improvement, the government brought in industrial engineers to redesign and optimize the JPJ's operational system. Next, let's talk about the industrial engineering tools and methods used in government operations, specifically JPJ. To further understand the root causes of the problems, industrial engineers use several analytical tools. So, first method they use is process mapping and value stream mapping. This can be done by documenting every step citizens took from arrival to service completion. They also identify redundancy in identity verification and form processing steps, which then the engineers map information flow, physical movement, and decision points. This method can help to track every step in the JPJ service flow. And the second method that they use is queuing theory and waiting line analysis. Engineers analyze arrival rates and service time distributions, and also they model various staffing scenarios to understand the bottlenecks of the flow. They also determine the optimal number of service windows needed during peak periods, which then can help to analyze customer arrival patterns and service times needed in order to smoothen the flow. Next, the engineers also apply lean principles in order to identify wasteful steps that could be eliminated, like unnecessary walking between stations. They also identify the excessive paperwork duplication, which is a very common issue, and also they identify waiting due to unbalanced workloads between the staff. And the next method that they apply is facility layout optimization. This method is done in order to reduce congestion and improve movement through the building. So the engineers has redesigned counter arrangement for smoother movement, and the engineers also revise seating and routing to minimize congestion. As for the final methods, which is called simulation modeling, the engineers has come up with a few solutions that can help the workflows, like new workflows, new staffing adjustments, and new layout redesigns. This process is done in order to allow them to test different improvements before making any real world changes. Based on the analysis, the industrial engineering team implemented several major solutions. First, they streamlined the workflow by reducing unnecessary steps and combining repeated verification stages. Like they reduced the process steps from 14 to 9. They also combined the verification steps into a single touch process. They also implemented a digital queue ticketing in order to replace the physical lines, which helps to remove congestion. They also redesigned the facility layout to create clearer service areas and reduce bottlenecks. This is done by creating a separate zone for different services like license, titles, and IDs. And they also introduced self-service kiosks for simple transaction. And they also managed to improve the signage for better customer navigation. In the of third solutions that the engineer has implemented, which is optimized staffing plan in order to create a more efficient staffing schedule. So employees were assigned based on peak hours. Like they did a dynamic scheduling during expected rush hours, and the engineers also implement cross-training employees to handle multiple service types. And they also do rolling breaks to ensure uninterrupted service coverage, which every time a customer walks in, there will always be an employee to serve them. With the help of the modern technology, the engineers also has implemented digital and automation enhancement, which is basically like they use digital tools like online appointments, electronic forms, and text alerts were introduced in order to reduce physical waiting lines. These are done by they use online appointment systems and pre-filled digital forms and also automated text message in order to alerts for queue position. As for the results were significant. The average wait time dropped from 95 minutes to about 30 minutes. Customer throughput increased by 45%, meaning more people were served each day. Paperwork errors decreased dramatically, and employee productivity went up. Most importantly, customer satisfaction rose significantly from 2.6 out of 5 to 4.3 out of 5. These measurable improvements highlight the impact industrial engineering can have on public services. As for the overall impact of industrial engineering in government operations, it helps in order to improve service systems, not in just manufacturing work. It also uses scientific and quantitative techniques in order to solve complex operational problems. It also enhances efficiency, quality, and customer experience in public sector environments. It also helps government agencies become more transparent, responsive, and cost effective. With that said, industrial engineering brings value not only to industry and manufacturing, but also to public services that impact millions of people.
Hello everybody. So in this case study, industrial engineering also helps to improve hotel industry, normally in housekeeping efficiency and front desk operations. Now normally hotel chain faces two major issues, which are the slow room cleaning and the long queues at the front desk. So for slow room cleaning, guests had to wait for rooms during peak hours, and housekeeping staff were also overworked in certain floors, and the cleaning quality might not meet the satisfaction of the customers. For the long queues at the front desk, usually during peak hours, the customers have to wait for the long queues and it creates the congestions in the lobby. Staff also struggle to balance check-in, check-outs, and inquiries for the guests. Then the customer satisfactions were affected. Nextly, industrial engineers also apply time and motion study. They will measure average cleaning time per room type. For example, single rooms, double and queen, and so on. They will also record non-value added activities such as walking, searching for supplies, and waiting time. This will identify variations between different cleaners. Next, they will apply workflow and processing mapping, which are also known as value stream map. They will document each step from guest checkout, cleaning, inspections, and release. They will highlight the bottlenecks and unnecessary steps. Third, for the layout optimization, they will analyze distance travel from housekeeping pantries to rooms, optimize the supply storage location, and also improve the layout of a cleaning cart for ergonomic efficiency. Lastly is called the lean tools. They will apply the 5S to organize supply rooms, standard work to ensure consistent room cleaning, and Kaizen for continuous improvement. Industrial engineers also optimize room cleaning sequences. Let's say they will let the cleaners to clean the room closest to the elevator first, grouping rooms to reduce walking distance, scheduling priority rooms for early check-in in requests that day. This will reduce unnecessary travels and allow the room's availability earlier. Secondly, standardized cleaning procedure, which is the step-by-step standard operating procedure (SOP). They will visualize checklists for each room type instead of assigning floors randomly. Rooms were allocated based on time required per room. Staff will also receive equal total workload minutes rather than equal group numbers. This will create a fairness and reduce fatigue. Lastly, for the cleaning cart redesign, the cart was rearranged so that heaviest items were placed at the waist height, frequently used placed in front, and separate compartments reduce the searching times. This would improve the speed and efficiency for the house cleaners. Next major issue faced was the front desk. So the methodology applied by the industrial engineers are workflow redesign. They will redesign the process flow to separate the check-in, check-out, and customers' inquiries. This will prevent all customers from forming one congested queue. Secondly, they will introduce a self-service kiosk for express check-in, billing, and express check-out. And this will reduce the front desk load up to 35%. Third, the staff scheduling optimization. An industrial engineer will use the arrival and departure data for peak hours were forecasted and dynamic staffing scheduling were created to ensure sufficient counter personnel. Cross-training enabled staff to support multiple roles. As a result, for housekeeping, the check-in time and check-out time were reduced, and the customer satisfactions were increased to 4.5 per 5. For front desk, the average cleaning time per rooms were reduced, and the room ready by 3 p.m. has increased to 92%. The cleaner walking time is also reduced. Now this shows that industrial engineering can enhance service quality and operation efficiency. Lastly, the overall impact. There is higher guest satisfaction, higher occupancy due to faster room readiness, lower labor costs from improved productivity, and it reduced stress and workload for employees. Now, this case study shows us how industrial engineering can solve real operation problems in hotels, such as enhancing the overall guest experience, improving efficiency, and reducing delays. And that's the end for our presentation for this assignment. Thank you very much.